My name's Vikram Rangnekar. I'm not, I'm not with any specific company right now. I'm just consulting, building my framework, and like trying to figure out where this whole LLM thing is going, and where I fit in. Um, my coffee, I just like any good like light roast. I love all the stuff that comes out of SF and like the Pacific Northwest, and they got. And if you ask me what's my favorite coffee, I'd say Cat and Cloud in Santa Cruz. Verve or Cat and Cloud, both those places you cannot go wrong with them.
What up, MLOps community? We are back for another podcast. I am your host, Dimitrios. Today, it's all about DSP. Vikram broke down so many concepts that I thought I understood, but I didn't. I'm not going to lie, I didn't. And you get to hear me working it out in real time. Hopefully, it helps you understand. Let's get right into it. All right, real quick, I want to tell you about our virtual conference that's coming up on September 12th. This time we are going against the grain and we are doing it all about data engineering for ML and AI. You're not going to hear rag talks, but you are going to hear very valuable talks. We've got some incredible guests and speakers lined up. You know how we do it for these virtual conferences. It's going to be a blast. Check it out right now. You can go to home.mlops.community and register. Let's get back into the show. Let's start by telling me what you've been working on, because I want to start there and then go into like the nuances of it and all the different challenges you've encountered.
Well, I started like building with LLMs a while back, and like a bunch of startup ideas. First one being this thing called 42 papers. Back before all the archive excitement, I predicted sort of like the archive is gonna like take off, and I wanted to build this like way to discover like what everyone's reading like right now on archive and stuff related to you. Like I want to see
like
the
trending.
papers. Sort of, exactly, but also like related trending.
Yeah.
And so I was like exploring ways, and I didn't just want to throw the papers out there. I wanted to like extract the key points and stuff like that and just show that. Like, forget the papers kind of thing, the whole paper. No one's reading the math anyway. So so I was
Fancy math.
yeah, and we're trying to figure that out. And we had this whole idea around let's get, and this was early, like 2017-ish, maybe, and we called it 42 papers, named it after the Douglas Adams whole 42 thing. So, and we had this idea where let's get all these people sort of like, the Amazon service where they can like, all these like PhDs or whatever can help us and do this, and we give them like points or money or something, karma, and we had this whole thing and we're planned, and I was like, you know what, I don't know how fast this is going to scale. It's going to be hard, and like get people like read papers and extract value and stuff like that. And so when I stumbled onto like the early models coming out of Allen AI, these were like BERT models and stuff like that.
Uh-huh.
And they had trained them on archive. And these were like small models by today's standard, like probably like I don't even remember, probably like 500 million parameters.
Yeah, maybe.
And the thing could summarize, and this thing could like summarize the paper. And the first time I actually saw it, I was like blown away. Honestly, till then I was very familiar with the ML world, from being at LinkedIn. They used ML everywhere.
And not to the best, but they definitely use it.
Yeah, I mean, they use it, right? It was ad relevance, fraud, and all kinds of stuff, right? Everywhere.
Oh, yeah.
Right? These are like not LLM models. These are not GPU models. These are models that ran on Hadoop or whatever. These are more statistics leaning sort of.
Yep. The traditional ML world.
Traditional ML. And I this thing was like magic, because that I could kind of, I could roughly wrap my head around what's going on. But this thing could summarize like a blob of text into like points. I was like, what just happened? And that was like really mind blowing. And then kind of I took, went down that rabbit hole. And I needed sort of like a framework. I realized to like build with these things. And so I started like an early, the early work of building a framework, and there was a lot of learnings around the way, and and it like evolved along the way, and that's where like I am today in terms of AX.
Incredible. So starting in with the fine-tuned BERT model for 42 papers, and then going from Mechanical Turk, I guess, is what
We
you were
dropped
using?
that real quick when we realized the model could just do that, right? I mean,
Yeah, it's incredible to see. And now it feels like you can still probably get what you're looking for with that fine-tuned BERT model, or maybe like a fine-tuned small model.
I think a fine-tuned small model, there were a lot of like issues with that bird model. There was like a lot of like literal heuristics, like, oh, if your word is like broken here, then let me just like join it together. There was a a lot of like, and they were sort of I think super, like, obviously they could do it, but a small model I think would not cost too much more or be slower.
Yeah.
And I'm not even sure if you probably need a fine-tuned model at this point. I don't know. I mean, some of these like really small models coming out today are like super powerful. There's
Yeah.
this Niston guy. He had this like merged model he launched yesterday. It was like he did this ternary one-bit quantizing on it. It came down to like 65 MB or something. And this model was like apparently like super fast and really good. And so,
Yeah, exactly. You can get so much further with some of the stuff that's out there these days. And it is funny to think about how now you, out of necessity, had to create something to help you along the way from that BERT. But along the way, things just blew up in the space. And so you were able to level up really quickly. And we mentioned too, before we hit record, that you're very much focused on the JavaScript, Typescript world because it is so fast and you can iterate and you can do things really quickly. So talk to me about, first, just like maybe give us a bit of background on what the actual tool is that you built, and then why this love for JavaScript, Typescript.
sure. So the tool I built, it's basically a framework. It's called AX, and it doesn't stand for anything really, just cool sounding name. I mean, you call it agent framework or whatever. I mean,
Yeah.
so the idea was like when I started, I needed initially a way to abstract out LLMs. So that was my first thing. It was like, okay, all these like client libraries have their own set of bugs and all of this, and these are just like API calls. Let me abstract this out. And that was just a simple goal, and I think I achieved that with like this pretty quickly, essentially. And then I realized on top of that, that's like, I need a way to improve prompting. And then I realized these blobs of text that I have to maintain, like, it's point 1, do this, point 2, don't do this, point 3, do that. And like, I hated that. Honestly, it caused me not to reach for an LLM more often in my like code. Because there was like this whole like dance I had to do, and then there was like loops around it to make sure it didn't break, and there was a whole bunch of stuff. And
I find myself too, just on that fact, really never being able to quit, because I always think the next prompt is going to be better. Yeah. And so it's like, I can never be like, that's good enough.
Yes.
It's because prompting
because
is
you
so
don't know.
easy. Yeah.
You don't know. And you don't know what word in there is messing things up. And
exactly.
And that just feels icky to me, and I didn't like it. I know instruction kind of following is obviously the way these things have been trained, at the final stage of training. But I was like trying to look for a better way, and and I tried a bunch of stuff. I was like, there was this templating thing and blah blah blah, and it just didn't quite fit. And then I stumbled onto the DSP papers, or the demonstrate, search, predict papers from Omar and Stanford. So the key, I know you've like covered this before, but essentially to me that they were like, so what's really interesting about that paper is there's this trend where people just take like an idea and then chop it up into like 10 papers, right? And all these papers are really light because now they have 10 published papers. But Omar like took all his best ideas and put it like into this one paper. And people don't notice that. Like people are like, oh, okay, it's like these examples, you can tune these models, but there's a lot more to that. If you start the paper, the first part starts with signatures, right? Like that signatures concept really, like to me, it made sense because they're basically functions. What they're saying is there are a bunch of inputs, a bunch of outputs, and then obviously with AX we took that even further. We added the concept of types on those things. So essentially, we say I have 2 string inputs and I need a boolean and a number outputted. Then we'll enforce that automatically. And that's basically what you need in your code. You want something with inputs and something with outputs. You don't want, blobs of text that you're like trying to substring through, right?
Yeah.
So that was a real clear abstraction to me. And then I was like, there's so much more that can be built on this abstraction, because these inputs and outputs, what are the, when put together, what is this? This is an API, right? Once you have this kind of structure on a prompt, it's very easy to like say, oh, this is not a prompt anymore. It's an API. And now if you have, and also another realization came on is you don't want to do too much in a prompt. There are talks by OpenAI guys and stuff. So I don't know the exact. I can't tell you the exact like technical reasons behind this, but essentially at a high level, from like a builder, you don't want a prompt to do too much. You want it because there are all these like tasks that these things are trained on. And when you essentially ask it to do something, the LLM is pulling on those tasks, and kind of like there is some sort of like a limitation because of the size of the LLMs and all of this stuff, your context size. Honestly, I don't know where that limitation comes from. But if you say, oh, can you classify this? Can you summarize this? Can you also call these functions? Can you also do this? Like, it's going to mess up more. Yeah. So you want to like focus it down, say, okay, let's summarize here. Let's take that output, let's put into another one that then does function calling based on it, augments it with more data. Then let's take that result, put it in a third prompt. Like if you have these like long context, yes, we do have longer contexts now, but that does not mean you can have a longer multi-step blah, 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 because these things are not trained for that kind of a thing. Even if you notice, like Google talks about needle in the haystack like tests, which is fine. Which is basically an extraction step. It's saying we put a lot of text and we can find the right step. They don't say you can also then do function calling and then do this and then do that, right? I mean, so there's this whole like multi-step like task thing. I think they refer to it as long horizon tasks. And most of these models are not trained on that yet. So, even though you have the long context, you still want to like get your work done as quickly as possible. Yeah. Yes, you can put a lot of text in there and then say, oh, you know what, find the things you need from here. But, you are limited to that. And then you want to take those texts and then do something else. And anyway, so the point is that it defined an API, and that API made it really easy to then plug in all these like workflows together. So if I have like an extraction step, a classification, a function calling augmentation step, and so it's basically sort of like code. Yeah. And that signature piece was really, really like, honestly, that blew my mind first. It's not anything like out of the blue. It's functions. But like to apply that idea to like LLMs is a paper unto itself, sort of, right?
Yeah, gives you so much more stability.
Yes, exactly. So with AX, we've taken that even further, because now these functions we focused on the concept of agents. These are basically these like sort of like prompts, but they have the capability to do multi-turn reasoning, function calling. Reasoning, as much as these things reason, function calling, and like try to get a task done. But when they call these functions aren't necessarily just functions like other like some remote API, but they can call other agents. Because there is this like input-output structure, you can easily plug agents into agents as functions. So now you can have a tree of agents, and you could have something like, hey, this is like the one that you ask this agent about the stock, about a certain like stock, and then it has like a agent, it calls like an agent to do like a analysis on something, and then something else, and something else, and then these 4 agents like return their results, and then this main thing like decides, okay, here's your answer, sort of thing, right? Yep. So it makes it really easy to plug agents together and stuff like that. The other thing with the paper that really blew me away was the concept of examples. So essentially, a lot of times we just talked about it. You put all these like instructions in there, and instructions are really great with large models, right? You want to like the bigger the model, and the way I understand it from the paper is you want to use these big models to generate these examples from these instructions. And what are examples? Examples are, if this is my input, then this should be my output. If this is my input, these should be my outputs, and these should be rich. Try to cover as much as possible. And then you plug these into your prompts. And now this allows the LLM to infer patterns that you and I might not even see. So it's sort of like if I told you to write something sort of like Shakespeare, but not, I mean, how do I really communicate that? I could use just his name, and that would infer patterns. But if I give it like an example of what I want, it's much more powerful, right? There are patterns in there that I couldn't even use, English words to communicate to you.
Yeah.
Right. So these patterns are what these LLMs are able to like leverage, distributions, whatever they want to call them. I don't know the exact term. And so this is just like, this took all my workflows like to the next level. Like they were a lot more solid. And how many examples can you add in there? There's a new Google paper that said add 1,000. Right?
Yep.
Obviously, I'm not going to do that, but like then input tokens are cheaper than output tokens. So use those input tokens to get more solid output tokens. You're not error correcting and all of that and wasting your output tokens, right?
Yeah. That's such a good point.
Yeah, so that's a sort of like the second piece here.
And that in DSPy, that's when they do the teacher-student type of stuff.
That is also in there. That is actually like a third step. So once you set the examples and then you do the teacher-student bootstrapping, that's when it uses these basic. So in DSPy, examples are very simplistic. You don't have too much information in them. You just have like the input and the quick output. And that's only of the whole tree. So it's sort of like if you have a tree of functions or prompts, whatever you want to call them, DSPy programs that does like a whole workflow. The examples, you just set it at the top, say this is the inputs, and at the bottom, these are the outputs I'm expecting. And then when the bootstrap iterates, it captures all the inputs and outputs of the whole tree. Do you get it? So essentially you have this like database of all those traces whenever you have a good output. So if you're, every time you get a good output, you say pause, save that.
Yeah.
Pause, save that. So essentially now you have a database of all these like good inputs, outputs that when you are putting your code into production, you apply them on those things. So this one gets its set of 10 great examples. This gets its set of 10 great examples. This one, and then the whole tree works so much better.
Yeah, and that's funny because I had heard others talk about how, and they weren't using DSPy, but they talked about how important it was for them and their workflows to have the high quality examples. And they were saying, I spend so much time just going around the web and collecting examples that I want. And I have a database of examples. So, and this was for marketing use cases, right? So if it's an intro to a blog, they go around and anytime they see a great intro for a blog, they'll collect that and throw it in their database. And now with these different tones, and then they try to label it so that they can say, this is this type of tone and this is this type of formality. And then they can give it in those prompts. They can almost reference like this database and say, here's what you're doing. It sounds like with the way that DSPy does it, you wouldn't even need that, or would you still want to have something like that? Or are they two separate things?
So it really depends, right? DSPy is about having exact examples for your inputs and your outputs. So if you're expecting like 3 things inputs, say you have a question, a context, and like and another thing as inputted, like and then you want the outputs and like a classification or something, some 3 things, and then you want like a category, and then you want like an output that's like a summary and something else. Then you want the exact inputs and outputs, like the whole chain as an example, right? But if you're getting it to do something and you want to make it better and you want to add these examples in there as like just a thing to improve the prompt, that's fine, right? Because your inputs could just be write me a marketing your first input could just be essentially, you could give it a marketing task. You could build like an agent to do marketing tweets or whatever. And then you could have the first input could be the task. The second input could be the examples that you're like sort of inserting yourself, like a context, and then it would just like the output would be the tweet.
Yeah.
Right. So
Yeah.
so essentially, yes, you could provide your own examples, but the examples that at a high level, they're not different. They're basically putting something in there based on what you want, like output. So you could use those as example outputs and build your own like sort of tree.
Yeah.
And they're just high quality things that you have handpicked, in the end. Because yes, even though the bootstrap thing is sort of like it captures all the traces in between, but the final input, and the final output is something you still pick, right? You say, okay, even though you're going through 10 steps, it's like when this is the input, sort of. I mean, it's not exactly that. I want this to be the output, right?
Yeah.
I like an output like this. And there may be 15 steps in the middle that you don't have to go and set values on, right? The LLM is, the values are flowing. The first LLM activates and that generates an output that goes into the second, then that activates and then goes into the third, right? I mean, sort of like function calling the next function, calling the next function. And now you don't have to sit and capture all the variables within all those, like the state within the whole chain of functions, right? And
yes.
That's really the key to like DSPy. It's basically saying that, yes, sure, set high quality examples, found them from the web or whatever, that's cool. And then we'll help you capture all of the traces in between so that when you put this into production, like there are good examples set for everything.
Yeah.
Because your tweet example might be good for like the final output, but it might not be good for the one classification or extraction step you have in the middle, right? That might need its own sort of example. So that essentially was like sort of blew my mind, because I was like, it's really simple. Again, none of this is like, but it really like solved problems that I was having, and I could see others kind of struggling with that as well. Yeah, it also allowed me to like take my models to smaller, take my work to smaller models and still kind of have that same performance. And something I'm like exploring now is there's more and more tuning APIs that are popping up, right? Every service provider has like their inference API, but now they have a tuning API. In fact, Gemini has like sort of made it like almost free to run small models. So if you take this information that DSPYs capture, you can essentially just push it to the tuning API and have like a tuned model, right? So then you might not even have to set those on the so I think there's a lot of value in taking this ahead.
Oh, fascinating. Yeah, and retracing our steps and going back to something that you said originally that I 100% agree with is the idea of making sure that the tasks themselves are as small as possible, but then where you can really let yourself go is the context that you're giving it on the task. You're able to say, and that's why I think the context windows are great. Having larger context windows are really useful, but the task itself that you're trying to get done, you're not trying to get 3 or 4 tasks done at the same time in the same prompt. You're just trying to say, do this one thing, do it really well. Here is all the context you need on how to do it. And then it outputs that. And then we can go along to the next thing.
And, there's actually a really interesting thing here. Even though we say that, people often do not realize they're adding another task. That's another thing I've seen often. So they're basically, it's like this, let's do this thing, and then I want JSON output. Guess what? You've added another task. So you don't realize that. You're like, oh, you know what? I got JSON everywhere. Like, yeah, but, dude, this is like, it's another task, and it's quite a heavy task now, So, like, that was another breakthrough that the paper had for me. Like, I have struggled with outputs, and I tried to figure my way around. And even early on, I realized that JSON and stuff was just like a nice to have. I think people, without like overthinking it, they were like, oh, I use JSON everywhere, so this should just pop out JSON. Oh, JSON doesn't work well, let me try YAML. I was like, no, what about key values? Just like, do you really need that nested structure out from this thing? Like, mostly not. So if you look at the paper, they use key values. And that's really great, because a lot of the models, when they're trained, they're also trained on the key value format. There's always like a title of what the thing is, and then the thing is, right? And then there are a lot of advantages to key value. Firstly, yes, there are no extra tokens that this thing has to figure out. It's not really like you're wasting tokens. Sure, that's maybe one thing, but it's like it has to generate those tokens, and then it's going to do a worse job on something else because it's making room to do that JSON, right? And then if you're like, yeah, but this so-and-so API does this really fine, this model provider. If you notice, often those things are slower because they're doing something else. It's sort of like having a second model or like trying to force it somehow, and the error correcting in the background, and they're like hiding that from you. And then what about streaming? Often these things completely break for streaming. Even like there are model providers, there are just like JSON streaming, function calling is broken, right? And they just don't, because no one's using that or something, maybe people who are using that just are like, whatever. But so the key value, the advantage of going just key value for inputs and outputs, or outputs specifically, is you can now process things as they stream in. So once you get the key and then you start getting an output and you're expecting the output to be a set of points, like say, 1 dot blah, 2 blah, 3 blah, you can now ensure, you can like literally validate it as it flows in. And if it's not doing the 1 dot blah, 2 dot blah, whatever, then you can like early stop and say, hold on, this is not what I want. I specifically want it to follow this format. That's the concept of assertions that the DSP white paper has.
Yes.
And so in EX, we took that further and we built something called streaming assertions. So streaming assertions allowed you to basically do this like early stopping on like whether on key values, like, okay, where there is like an output, which is like a summary, and then the summary. And sure, I look at the whole summary and I can then decide, oh, this is wrong, blah, whatever reason. Or while the summary is streaming out, I can actually look at the thing and say, oh, you know what, I wanted this is in points, and this is not in points, stop. Now this obviously is good because it's early stop, so you're gonna, your latency and all that is better, and you're gonna save tokens. So, this something is really, that's possible. That's not possible if you go any other route, right? And it's built into the framework, so you don't have to like sit and try to write this complex thing. And because the framework is vertically integrated, like there's no dependency. So AX has like 0 dependencies in the packages. So it's the APIs, all the LLM APIs are built from scratch. So the beauty of that is we can actually like, vertically build the most solid thing we want. So we want streaming assertions or whatever, right? We can just build it now because we don't have to go past the boundary of someone else's, like,
And I didn't quite understand the idea of these assertions and building out the API, basically being able to validate the type.
Yes.
And how
and
you
structure.
said, all right, well, one abstraction is what they were doing with DSPy, but another abstraction is saying this can now be an API. And so when we give whatever output to someone, it comes in inherent with the idea of it's going to be in the type that you specify. Is that what I understand?
Yes. So there are 2 types of assertions. One is you put them, you assert a type. Essentially, you say, while you're creating the function signature, you just say this output type is string or string array or number or Boolean or whatever. Or, and the second type of assertion is like a custom function where you want to like actually do something with the output. You might actually call another LLM if you really want. You'd be like, hey, is this good enough? If not, throw like a error, essentially, and then the first LLM can correct itself, right? So it's a function called on this output value, and this can be done either when the whole value is available. You can wait till the end of value. You might have like multiple key values that are outputted, so in which case then you might want to look at the whole value, or you can do it as the value is streaming out. Because it's not JSON, if you can somehow validate it, maybe, you're looking for some prefix or something before, so you can chop up every line that's coming, wait for a line to come in, then kind of look at it with the regex and saying, sorry, you're messing up, sort of thing.
Yeah.
And this early failure is great because now, firstly, the assertions concept makes it easy to code because now you have all of this like captured within your DSPy program. And when you initially put in the examples and you run the bootstrap, all of this gets engaged, right? So the error correction, all that. So your outputs, all the traces are high quality in between because the assertions have ensured. So in production, less of this stuff happens, right?
So,
Because you've already fine-tuned it down to the correct, what you need in terms of code. You're not saying, please add a dash in front of, like you have an assertion. It's explain that. So you got high quality examples. You just save those in there and the LLM knows, I know what this guy needs.
I see. Oh, okay. And one thing that you mentioned before we hopped on too is that you feel like there's not a lot of people really thinking about building with LLMs, or sometimes the way we go about building can be off. And it makes me think about some of the stuff that I tend to talk a lot of shit on, how the things that we are building aren't really that valuable. And so I am looking around and saying, like, this is the future we were promised. This isn't what I was hoping for. So what's your take on that?
One caveat, I would say we are still early. So, we shouldn't forget this came out like, production ready, sort of like, beginning of this year, mid last year, maybe, so we're like super early. I think people just haven't built their LLM muscle, right? It's just like a lot of people don't reach for an LLM naturally yet. I mean, there's so many like, this is that joke about how like, just Google it or whatever, right? And now just don't ask me sort of thing and like just LLM it. And I think even in code, people haven't wrapped their head around what's possible. Like, I've come across people who do not believe LLM can write stuff. Like they're like, yeah, but it's not as good as blah. I was like, yeah, that's because you just like prompted it wrong. He's like, oh, I tried it. I was like, hold on. Did you try that with ChatGPT 3.5 free? And, he's like, yeah. I was like, dude, you're like whatever engineer in this company, pay the $20, get GPT-4 and then, like prompt it better, give it some examples. Yeah. Right. So it's sort of like people like, I think haven't like internalized it. And yes, I don't think a lot like I experimented with tooling startups. So I was experimenting with the observability sort of space, seeing, maybe there's something I can build there. That I tried like I experimented with this another tooling idea where we'll build like make it easy to build these LLM workflows and everyone, it's so early. Then obviously these spaces are super crowded. So I'm not like I'm kind of holding off to figure out what really is the thing here, but also customers, right? I mean, they're most are like just not. They don't have the people to build this. Essentially, I think that's really like the job. I feel AX can help with is make it really, really accessible, right? Like I think the model guys are doing a phenomenal job. They're accelerating much faster than anyone else, and a lot of the people building like on the framework end of things, I almost feel like they're not building with real customers, because I see a lot of like overcomplication of stuff and like, it's not production ready. There's like there's no telemetry. Like AX has open telemetry built in. So there's
Nice.
already tracing happening. So you plug in a tracer like from, open telemetry is like an open standard.
Yeah.
You can plug in. So a lot of these frameworks don't have that, for example, just built in. And, there's a lot of like production stuff that you need. It's, there's just lots of dependencies. And then you're, like every little like NPM for this and that and whatever, Python.
Things break all the time.
Yeah,
because
and
of
people,
that.
Obviously don't want to use stuff that has all of that. And then they have this created the whole world on top of their own like terminologies and blah, blah. Like, that's why I like DSP. Why? Because it's sort of like standardizing some of that. And there's a lot more people saying, oh, okay, you know what? If all of us can have the shared understanding, this open thing with like, that's, an open paper, it's going to help. And then the framework on top of that helps with all of this other stuff because it actually implements it and takes it like, steps ahead. But yes, I will tend to agree with you. People need to build more useful stuff.
And you're thinking about it at not even at the level of what's the actual output there. You're just thinking about how difficult it is to get to that output because of how we've architected this ecosystem. The ecosystem that we live in is just convoluted, and it's like,
I mean,
whoa, I gotta hit it.
LLMs are also raw, right? I mean, they're like raw power, and you have to sort of like, help someone like, You just like cannot throw a guy into a Ferrari and be like, just like you sort of have to give him some way to control it. And I feel like one good example is really like like stop what do you call those things, like word limit, like generation output limits, right? And often sometimes you might have like a small output limit and you hit it, and then a person doesn't really know why his workflow is not like working, because like somehow the framework's not exposing the fact that this has stopped for this reason, and I've seen people struggle with like things like that, because a lot of these frameworks and stuff are sort of immature in that sense, right? They haven't or for example, why not just continue, right? Why not have like some capability in there saying that if you do hit the output count of like 200 tokens, then just like then run it again and then again until you get your exact structure that you need out, or this whole thing about like JSON everywhere, and people struggle and cry about it not generating JSON. Like, you just have a key and a value, have another key and a value, have key and a value. Do you really need this value to have another key and value, and then like, this whole whatever? You don't. I mean, or just leveraging multimodal. So AX, like when you have the signature, these are inputs and outputs, right? So the inputs don't always have to be text. They could be, because now these frameworks models support multimodal, they could be images. So AX has that built in. And how do you make that work with DSPy? That's not in the paper or anything. So there's a lot of stuff that AX is like taking the paper and then build stuff on top. Like, yes, those things are still examples. So people forget those images are base64 encoded or whatever. They are still part of the prompt. So they can still be captured as examples. And there are patterns in those images. So, so you can have images as examples with text. So if you have like something that classifies cat, like, I don't know, cat faces, or something like, is this cat happy or sad or whatever? And then you want examples. And now if you run through this and you give it a few examples and get all the traces right, now you have your examples contain like, stuff about the cat, maybe some text blob, and then like the image of the cat's face or something. So that like almost no framework's doing stuff like that, right? I mean,
yeah, trying to just think about it as how can we give it a richer prompt so that there's better understanding.
And make that work with the whole DSPY examples, tuning, and all of that.
Yeah.
Basic
One
stuff.
thing that I know it took me a while to wrap my head around, and now I can't even remember how it works, but I would love to know if you messed around with it, was the idea of like compilers in DSPy, or I don't think they're called compilers, they're called something else, but Omar was telling me to think of them as compilers. And that's where Omar and team have had to spend the majority of their work, because it is something that most people just have a really hard time wrapping their head around, but it is very powerful.
So I think what you're talking about is what they initially called teleprompters, and then they realized people are getting confused, and then I think they call it compilers now. I'm not 100% sure, but I think that it's basically the whole bootstrapping stuff. Basically, a thing that takes the basic set of inputs and examples, where you have a model, you have a teacher model. I mean, a teacher model is just basically a big model. And now you're not really teaching a small model, you're just doing a context. You don't really need the second one, but sure. And then you set some examples on it in terms of like your top level input and your final output. So, and then the compiler basically iterates on it with some kind of strategy where it runs that once, and then maybe it like changes the temperature a little bit, or it changes something else a bit, and then runs it again with another sort of like adding some sort of entropy to the whole thing, and then like keeps running it, and then you evaluate the output. You can like manually do it, or you have some sort of function or another LLM, and then you find like the traces are in the DSPY paper, they call it demonstrations. That's basically the inputs and outputs of the whole chain.
Yeah.
That are stored. That is a compiler. But they have other compilers too. They have something called MIPRO. So that they have a whole range of them. And I haven't really dug in. There's new research coming out about MIPRO, which is actually kind of optimizing so there is, I know I'm talked a lot about examples, but there are some level of instruction. So there are like the prompt signature does get compiled into a prompt. And there are some level of like text, the high-level instructions that you do give it, like, okay, here, I need you to classify the faces of these cats or whatever. There is some instructions. And the MIPRO, at least cursory, what I kind of glanced through the paper, is a way of like doing this kind of iterative trying to come up with better text that improves the output of the LLM. With the, like, instead of saying, classify the faces of these cats, it'll say, whatever, dwell on the features of this cat and come up with, whether it's happy. I don't know, whatever, right? I mean, and just like changing the language there gives you better outputs. So there's research happening there, solid stuff. I mean, I'm going to incorporate all of that. But I've just focused on, like, people aren't even using this right now. That's like, let's get people to use this. And even just setting examples, you're already like, 80x, like 100x from where you were.
Yeah, your capabilities go up so much. And I had a friend talk about all the different ways that you can think about using LLMs, because a lot of times you get stuck in your capability or what you think it should do and how it should do it. And he just has been compiling different personas that he tries to give the LLMs. Like, one is a critic, one is the, what was he calling it? The adapter. So there's all these different personas. And then when you look at that, you can get inspired and you can think, okay, well, maybe I could plug it into this little piece of my workflow or whatever.
In EX, those can be agents, essentially. You could have these like personas, which are basically like agents. You can even give them some tools. Like, you can say this has this persona, and it also is able to use these tools to do this thing. It's like, I don't know, the searcher or something, and then the researcher, and then you connect it into like an archive API or something, like, so it's able to, like, and then you improve that little guy over time, giving him a little more capabilities, improving him to, like sort of like independently. And then you can plug him with AX into any workflow you want. So you're doing something with like stocks or like some papers, research, and you can say, oh, here, I have this like scientific researcher. Let me plug him in.
Boom.
And now suddenly everything improves because now it has that extra capability, right?
Yeah.
That the little agent comes with his own context, his own examples, his own functions. He doesn't pollute the main flow, essentially.
And when I'm building out that little agent, I am, as you said, I'm tuning it so that I get the best performance for that specific small task that I'm going for. And then I can plug him into the greater Lego masterpiece.
According to the DSP, he would get tuned into your workflow. So he would not come with his own examples or state. So essentially, when you plug him into your workflow and then you run the DSPY compiler or the bootstrapper or whatever you want to call it on it, then he would get his, like, as the text flows from the top to the bottom, his examples would get preserved, the ones that have, result in good outputs for you in your workflow. Does that make sense? Sort of like.
Yeah, I'm just thinking about, so I guess maybe I'm not thinking about agent examples per se, but I'm thinking about one use case that we had on here like a year and a half ago when Philip from Honeycomb came on, and he said they have certain things in their product, and the product Honeycomb can be fairly difficult sometimes to figure out what and how to do what you need to do. And so for that, they said, oh, well, just prompt it, figure out, and then ask what you're trying to do or tell us what you're trying to do, and then we will try and do it for you.
Sure.
And on some level, I can imagine that's a lot of agents going, especially if it's the doing it for you. If it's just, hey, let me pull up a document page that'll show you how to do this, that's one thing. But if it's let's go and now let's try and do what you're trying to do, it's a whole nother thing. And so
in AX, there's some support for that. The way to do that, again, I'm coming back to the start where I just said, like, you got to chop the problem up, right? And now there are different ways to chop the problem up. So when initially you get a task that's asked of you and that's broad, saying, hey, I need you to do my taxes. And then you come in, hey, I need you to, I don't know, classify my cat's face, right? They're two pretty different things. And now if you put a lot of agents, you get an LLM to make this decision, right? You can. I mean, that's one way to do it. You could have these, but there is some, you can give 20 basic agents or functions, whatever you want to call them, into the main thing and say, oh, your job is only to send the control to one of these guys, right? Basically hand off control flow. And then, that agent sort of takes off from there. Or there's this concept called a semantic router or routing. So now there is this whole world around routing LLMs. There are startups that are funded here.
Yeah.
And AX comes with something called a semantic router, where basically it uses embeddings to classify, sort of like find the closest match to send your task down. So if you send it like a blob, you say, I want you to classify cat faces for me, then there's like a router set up which says, oh, anything to do with cat's faces, I want you to call this function, sort of. Or anything to do with like taxes, call this function,
But that assumes you've seen the question before, right?
So, no, when the question, I mean, you're working with a finite set, right? You have functions there is only a finite number of things you can do. You cannot just, if you ask the honeycomb thing to go, I don't know, find your grocery list or hotel bookings, it might not be able to do that, right?
Yeah.
So there is going to be a finite list of things. So once the question comes in, you embed it, and then you have this router which already has embeddings in it for each one of its routes. You find, you do like a dot product, find the most closest similarity, and you send it down that and say, okay, let's activate that pipeline. So the advantage here is it's dirt cheap with embeddings. It costs literally it's almost free. And there's no overhead of an LLM being engaged until it hits that path, right? So now you can have far more number of things possible. You can have hundreds of things that could potentially, or thousands, that your initial input could go down, right?
And all these workflows have been created and then tuned through these methods that we're talking about.
Yes, exactly. Yeah.
So it's really not like
these workflows are just like code. It's just code. It's like functions, right? It's like a function which has more functions in it. That's that's the only way to think about it. And because the signatures are so tiny, you want to call and use these. You just want to, this is almost one line to engage a DSPY program in your code. And it looks like a function call. You have some inputs that you pass in. You call this forward function because that's why DSPy is in PyTorch, and PyTorch had the forward function.
Yeah.
I kept that. I'm still conflicted. I think I should call it run or something, but it's not like none of the prompt people care about PyTorch, right? I mean, it's too low level a thing. But anyways, so it's so easy to invoke. So people want to use it. It's like a function call. You just give some inputs, you wait for the output. Inside it, they might do a whole bunch of stuff, engage your examples, do multiple function callings, do assertions, error correction, whatever. And boom. And finally you get your 3 things that you want out. And then you call the second function. You pass those as inputs to that, get it out. You might even call 3 in parallel. Use some, whatever async thing and say, oh, okay, I'm going to send it down 3 more paths, and then I'll wait for those to complete, and then I'll get the answer, and then it's essentially a graph or whatever. It's like a small program, but it's all LLM based.
And all of these different workflows, you're shepherding them along, or you're tuning them to make sure that they are giving you the best output. So
Yes.
It's not like these workflows are just created by the LLM and then you stand around and say, is it going to give me the right thing?
No, you're setting examples on each one of these subtasks, the best examples you can have, and you keep improving them over time. And that makes each one of these subtasks solid, because each subtask is it's its own clean context, right? It has to have its own set of examples. It cannot have the examples of the top level task or the task besides it or the task below it. It has its own unique inputs, its own unique outputs. It could be a subtask in here or a subtask somewhere else, but it sits independently. It says, my job is to take this text that's coming in and classify it into these 4 things, maybe. Or my job is to extract out the right I don't know, tax sections based on this thing. So now it needs its right examples for,
So cool, man. Well, thank you a ton for doing this, because you're opening up my eyes to ways that agents are being worked with that I've talked to Omar before, but I love seeing you take that inspiration and then build on top of it and say, here's, as you mentioned, here's the open paper, here's what we can standardize against, and now what can we build with it?
Exactly. Yeah, you're right on. Let's start building. That's basically it. I'm there to help. Let's build all these things. Let's fill into that valuation.
Yes.
Let's prove Goldman wrong.
I love it.